talking today about modeling with functions. And we're going to basically use a function to really solve real life word problems. Now, here's the thing I want you to get, and probably this is the most important part of the lesson in regards to what we need to understand here, and it's this. We talked about an ordered pair. We talked about X and Y. We also said that, when we're talking about X and Y, that the domain is X and the range is Y, right? And not only that, then we begin to talk about functions. We said, well, the input is X and the output is Y. We're adding one more thing. The independent variable, those things I had you just write down from that previous slide, and the dependent variable, those things are related as well. In fact, we've got four names really for the same thing. Our X coordinate is the independent variable, it's the domain, and it's the input. And our Y coordinate is the dependent variable, the range, and the output. All those really basically 8 words to describe only 2 things. So it's really important that we understand if I said X, you should associate with that domain, independent, and also input. And if I said Y, you should tell me that that's the dependent range, the output. If I said like range to you, you should immediately just say Y. If I say domain, X, let's try that right quick. All right, you listening? All right, domain, X, good. All right, one person had it. Y'all got to join. Range, good. How about output? All right, input. Exactly. Dependent. Y, that's a new one. Dependent. Y. Independent. X, okay? So we're just associating those with those coordinates, and it's really that simple. So I want to look at, okay, how does that actually relate? How does that work into a real world problem? Well, we've called the X value the independent, and we've called the Y value the dependent. Well, let's talk about what independent means. What does independent mean? Any ideas?
Be by itself.
By itself, okay. It's by itself. It's, let me ask you this. Austin, if you don't mind, are you independent? It's a trick question, really.
I don't know.
Oh, you don't know? Okay, that's a trick answer, I think. Think about this for a second, Austin. Okay, when I'm talking about independent, let's just say, we have people who have independent personalities of their own person, that kind of thing. But really, in this case, what I want to know is, do you function all by yourself? And in order to do that, you'd have to have a job and pay your own rent, pay your own bills, pay electricity, the water bill, pay for your car payment, et cetera, take yourself places instead of somebody taking you in a ride. And so we know, a freshman year in high school when no one's independent, yeah, but you're getting a lot closer. Independent means that you are kind of in charge, but we'd have to say that you're dependent. All right? And not only that, well, we'd have to say that your parents are the independent side of things, and they're probably the ones that say, hey, you can do this, or no, you can't, right? They're independent. So what we're looking for is when we look at a problem like this that we're modeling, we want to know what it is that is independent about this and what it is that's dependent. For example, let me just read the first one. In the winter, more electricity is used when the outside temperature goes down and less is used when the outside temperature rises. Now, back up just for a second. Remember, the dependent variable depends on the independent variable. Okay? So what we're looking for is what is independent and what depends on the independent variable. So looking at this problem, what changes and what is controlled by that change? So what's independent here? Well, we got a couple of things. We've got electricity, the amount of electricity used, and I see temperature. What's independent? Yeah, you have no control of the temperature. Yeah, the independent variable here then is the temperature. And what is the dependent variable? Yeah, the amount of electricity. It's that simple. It makes sense that when we are in our homes at wintertime, when it gets really cold, we have to crank up the heat, right? It uses more electricity. If it's not cold outside, we don't crank up the heat. So we can't control the temperature, but the temperature controls what we do with the heating system. Look at the next one. The cost of shipping a package is based on its weight. So what is the independent part of this and what is the dependent part of this? Jesse, please turn on your video. Do what? The weight, absolutely. The weight is independent. They can bring in a box that's heavy or light, but the dependent part of this is right. The dependent part of this is the cost of the shipping. The heavier it is, the more it costs. If you want to jot down your notes here, you might just say, the independent tenth. Okay, and it's okay to abbreviate. When you take notes, you want to abbreviate. The dependent amount of electricity. Whatever you can abbreviate so you know what we're talking about here. Well, as I mentioned earlier, these notes are going to be kind of short today, and we'll pick up with it Monday. I thought about giving you all the notes today and then give you an assignment on Monday, but I thought it'd be bad business for you to forget all weekend just to pick up clean. So we'll give you part of the notes today. Well, let's talk about how that's going to relate, this concept of an independent variable and a dependent variable in relationship to functions. The dependent variable, we've already said, is X or Y. Which one is it? Y, yes. The dependent variable is Y, and it is a function of the independent variable, which is X. In other words, we might say it this way. The dependent variable, which is f of X, is a function of X. So the dependent variable is a function of the independent variable. Now check out this example here. Amanda babysits and charges $5 per hour. What's my independent? I'm going to start my independent variable. It's on this side this time. What's my independent variable there?
5.
What?
5.
I didn't understand.
5.
The time, yes. Or the hour she works. So okay, and then the dependent variable, or the dependent part of this is what? It's the longer she works, what does she make more of? Money, yeah. So the dependent part is the money earned. So the money earned is is 5 times the hours worked. So, we might want to write it this way. We want to say, okay, let's let the X, okay, and that's going to be, remember, the independent variable. So that's just our hours worked. So let X equal the hours worked. You could have said H for hours. That would have been fine. And so if we go to write a function, we know that we're going to have to multiply X by 5. I'll write this way. That's $5 for each hour. And I went to write a function then my Y, or my dependent variable, the money I make, f of X, is equal to 5X. So basically, it's a way of writing an equation, which is my goal. But the cool thing about a function with this concept of input and output, concept of independent and dependent, I can write a function or an equation that can change depending on what my independent variable is doing. With that function, I can figure out how much I would make in 4 hours or how much I'd make in 1 hour and do it rather quickly. That's the point of a function. Well, we're going to stop the notes there for today and pick up there on Monday. All righty, so set your notes aside, and on Monday, you'll get part 2 of modeling with functions.